All right, this is 3.3, where we're going to learn the last two rules of our conditional and biconditional truth tables. So what you're going to do is when you look at this, we've got two situations. This is a conditional statement, and remember, a conditional statement is a single-sided arrow that looks like this, okay? So if I tell you that I am going to, if you get an A in this course, I will buy you a car. So the first case is if we start with a true statement, you get an A, I buy you a car, then we have satisfied both of the requirements. If you get an A, but I do not buy you a car, that is going to end up in a false result. That is the only time that we get a false result. If you do not get an A, but I buy you a car anyways, then you win. You get an extra, you get a car for nothing. And then in the last case, if both of us don't uphold our bargain, it doesn't matter because we didn't do what we were supposed to, so we still get a true result. So the only time that we get a false result is when we start with a true and we go to a false, okay? So that's the table right here that you will need to understand. And here is the case that says the only time that it's false. So now what it's going to look like is you're going to have to fill in pieces of the puzzle. The first thing that we're going to do is we're going to take the Q column, everything in Q, we're going to make the opposite by negating it. So trues become falses and false becomes true. Then we're going to go over here and we're going to take everything in P and make it the opposite. So the trues become false and the falses become true. And now we're going to arrow, and it is very important of the direction of the arrow. We're going to start with the not Q column, and we're going to arrow to the not P. So my answer, false going to false, is a true result. And I'm going to color that to purple here. True going to false, that is the only case where we get a false because a promise was broken. You got your A, but I did not buy you a car. False going to true, that is true, and true going to true, that is also true, okay? So we're going to let you practice that one on your own, and we're going to come down here to a biconditional statement. Now, I'm going to look at this biconditional statement. I'm going to show you the results of why a biconditional is the way it is. So remember, a biconditional has two arrows, okay? So I'm going to look at two conditions. I'm going to look at P going to Q, and then I'm going to look at Q going to P, okay? So when P goes to Q, I go this way, and that's true. That's false, that's true, and that's true. And then when I go in the other direction, Q going to P, that's true, that's true, that's false, and that's true. And now when I put them together, this is an and they're only true when they're both true. So this would be true, this would be true, and these two would be false. And so now if you look at the relationship, the only time you get a true answer in a biconditional is when the starting values of the statements are the same. And that's the rule that we're going to write. A biconditional is true only when the component statements have the same truth value. Either they're both true or they're both false, okay? So now we're going to practice how we're going to go about doing these tables. So the first thing is I'm going to take this P and I'm going to negate it by making it the opposite. So that becomes false. Then I'm going to take Q and I'm going to negate it. And so that becomes false. And now I'm going to go from not Q to R. Okay, so sometimes I like to do this. Not Q going to R. That is false going to true. And that is true. And then I'm going to find my answer by the not P. So here's not P. Double arrow to this last column that I did. So I'm going to do not P, double arrow, not Q to R. And so I'm going to fill in underneath. Not P was false, double arrow. Not Q to R I found was true, and those are different values. So this has to be false because the only time a double arrow is true is when they have the same value. Okay? All right, so the next one, we start with T and we go not T, makes that false. S and U, okay? So remember, S and U, that would be true and true. And the only time an and is true is when they're both true. And so now I'm going to do a single arrow from this column to this column. And I'm starting with a false and I'm going to a true, and that is true. Now, sometimes MyMathLab will build on these problems, but we're going to just kind of practice through a bunch of these and see how we can, kind of work through the process. So in this one, you have to actually fill in. I'm going to make a not P column, and then I'm going to have not P arrowing to Q. So the not P column is going to be the easiest. Everything in P becomes the opposite. So I've got two falses and two trues. And now I'm going to arrow from this column to Q. And I like to draw the arrow that I'm going because that's how I'm going to start. I have to start with the not P. And so false going to true is true. False going to false is true. True going to true is true. And the only one that is false is when I start with a true, I break my promise, and I end with a false. Okay? Now, this one I'm going to show you how we're going to write it. The first column we're going to do is P or Q. The last column is going to be P and Q, and then we're going to have the answer with the arrow in between, okay? So remember, this is an OR, and the only time an OR is false is when both are false. So if I put T or T, that's true, that's true, that's true, and that would be false. And then if I do an and, okay, so this is an and it's only true when both are true. So if I do T and T, that's true, and everything else is false. Okay? And so now my answer is going to be the arrow from this column to this column. So that's true, that's false, and that's true. And so my answer, I'm actually going to erase these. Ooh, I don't know if, whoops, I knew that was going to happen. So I'm going to do that again. Okay, so this would be true. So my answer is going to be in this column that I'm going to highlight. These are my answers. So true, false, false, and true. Okay? All right, the next one, we're going to do not P, and then we're going to do not P, double arrow to Q. So the not P column, this should be by far the easiest. False, false, true, true. And now we're going to go, and because it's a double arrow doesn't matter the direction. I'm double arrowing between these two. And remember, a double arrow is only true when they both have the same value. So my answer is going to be true in the middle and falses on the top and the bottom. Now, the way that they do this in MyMathLab is they may have you write the symbolic form first and then construct the table. And so when you read this, you're going to have this statement right here. You'll be full of energy all day. That's going to be P. If and only if you eat a breakfast, so eat a breakfast with eggs and toast, that's going to be Q. And then you won't be alert during your exam, that would be not R, okay? So the first thing that we want to do is we want to share the relationship, because if you notice there was a comma after toast, we're going to put these two things together. So this first drop down box is going to be P if and only if Q, okay? And then we have to figure out what not R is. And then we're going to do the or in between. And so this right here is basically going to be P double arrow Q or not R, okay? So let's go ahead and figure out the P double arrow Q. And remember, a double arrow is only true when they have the same value. So these would be true, and this one would be false. Then I come over here to R, and every R becomes the opposite. And now I do an OR between those two columns. So I'm going to put ORs, and an OR is true. An OR is false only when they're both false. So that's true, and that is false. Now we have some special definitions, self-contradictions. And self-contradictions is when you get a table of answers that are all false. And so I'm going to show you an example. And this is really, you can go through it. I mean, it's good practice of, doing all of these things. So the first thing I want to do, I'm going to do the easiest things first, okay? And so the first thing is I'm going to copy down P. So I'm just going to recopy what P is. And then the next easiest thing I'm going to do is I'm going to negate Q. So I'm going to make all of these the opposite. Okay. And then I'm going to go to the first column, and the first column says I'm going to double arrow between P and Q. Okay, so we've got double arrows between these two. And remember, a double arrow is only true when they have the same value. And so the middle ones are going to be false. Now I have to double arrow between the P and not Q. So now I'm going to go to this one, the double arrow. And remember, the double arrow is only true when they have the same value. So this one would be false, this one would be true, this one would be true, and this one would be false. And now my answer is going to be this column and this column, okay? Because if you look at the things, I'm comparing the first parentheses with the second parentheses, and the second parentheses is in the double arrow. So an and is true only when they're both true. So if I highlight, I've got a true and a false and a true, false, true, true, false. And so every one of those answers is false. And because I ended with a column of F's, that says that it is an implication. Oh, excuse me, not an implication, it's a self-contradiction. Okay. Then the next one is a tautology, and a tautology you have to say with an English accent, and that's when you have a column of nothing but trues, okay? So we're going to look at this one, and we're going to start by taking the Q column and making it opposite. And then we're going to take the not Q column, single arrowing to P. So we're going from here to here. So this would be true. This would be true. This would be true. And then this would be false. And then we're going to take that answer, and then we're going to do an OR between these two. And so an OR is only false when they're both false. So true, true, true. And that tells me that because these all are true, this is what we call a tautology. Okay? And then the last type of definition that we have is that when you have a tautology that are conditional, which means arrows that end in trues, these are called self-implications. So I'm going to just run through this one chart, and you'll see that this is an implication, and then I'll probably stop here and upload the completed notes, okay? So the OR statements are right here. And so ORs are true when one is true, both is true, but if they're both false, that is false. Then we go to the not Q column. So that becomes false, that becomes true, that becomes false, that becomes true. And then we have to do the and in between those two. So an and is true when they're both true. So that would be false, true, false, false. And now we're going to just copy down P. So I'm just going to translate that. So true, true, false, false. And I'm going to arrow from from this column right here to this column. So false going to true is true. True going to true is true. False to false is true. False to false is true. And because of this column right here, and it was an arrow, a condition, this is a implication. Okay, so I will complete the uploaded notes and you can review over these and let me know if you have any questions.